Hey folks, welcome back. In this video we're going to look at nuclear fusion reactors, so let's get into it. Now we've already seen how nuclear fission reactors work, but we're going to delve deeper into how nuclear fusion reactors work and the challenges involved. It says here that scientists are currently working on using nuclear fusion to provide energy, and remember nuclear fusion is the joining together of two lighter nuclei to form a heavier nucleus with energy being released. And here we have an example of a nuclear fusion reactor in which plasma would exist so that the nuclear fusion reactions could take place. It goes on to say here that when hydrogen atoms fuse, the nuclei must come together. However, the protons in each nucleus will tend to repel each other because they have the same charge, i.e. a positive charge. So special conditions are needed to overcome this: high temperature and high pressure. So the high temperature gives the hydrogen atoms enough energy to overcome the electrical repulsion between the protons, whereas the high pressure squeezes the hydrogen atoms together. So this combination of high temperature and high pressure is needed in order to fuse hydrogen atoms together, which we would want to do in a nuclear fusion reaction to form helium, for example. It then says it is these conditions which are needed to create the plasma, i.e. a state of matter in which the reactions can take place. And you might know plasma as the fourth state of matter in addition to solids, liquids and gases, where it's thought to be a sort of mix between a gas and a liquid. So we need high temperature and high pressure conditions for plasma to exist in order to have the reactions take place. However, this poses several difficulties for us. Firstly, we have a difficulty in finding a suitable coolant to extract useful energy from the heat produced by the reaction. And we also have problems with containment, otherwise known as plasma containment, to prevent the high energy plasma from physically touching and therefore melting any parts of the reactor. This is achieved most commonly by using strong magnetic fields. So we can use powerful magnets to keep plasma in place and stop it from touching any parts of the reactor, because if it does, then the plasma will cool down and the reaction will stop. But not only that, it will also melt the parts of the reactor that it does touch, because plasma is hotter than any known material. So we need these strong magnetic fields to contain it and keep it where it is. Lastly, it says here that the heat energy generated by the fusion process is used by heat exchangers surrounding the fusion reactor to convert water to steam, which drives generators to produce electricity. So in actual fact, the latter stages of this process are identical to the ones for nuclear fission reactors and fossil fuel power stations, where heat converts water into steam to drive turbines and then generators to produce electricity. So these heat exchangers take the extreme heat produced by the nuclear fusion reactions and use a suitable coolant to try and extract useful heat energy, which can then be used to heat up water. That's all for this video, folks. I hope you found it useful. If you did, give it one of these, subscribe to the channel, and I'll see you in the next one. Take care.